afternoon and welcome to our YouTube channel. This afternoon we are going to look at how to administer fluids to patient who has sustained burns. Now we are going to be very specific. We are going to look at the administration of fluids using the Parkland's formula. Parkland's formula. Now, before we get into our lesson for this afternoon, if you are watching us for the first time, please subscribe to our YouTube channel for more videos and insight about nursing and what is involved. Now, let's look at this example we have. Okay, now the example we have here, we are going to use it's the Parkland's formula. Now, what is the Parkland's formula? Now, according to Parkland's formula, in terms of fluids replacement, this is the formula we use. Okay, it's 4 mils times the percentage of total body surface area base times the patient's weight. Okay, so this is the formula we use. We multiply 4 mils times the percentage of body surface area times the weight. Now, I'm interested with the TBSA, the total body surface area base. Now, the total body surface area, we use what is known as the rule of 9. Okay, now under the rule of 9, we have given, for example, this is what we use. Under the rule of 9, each part of our body has a particular 9 which is allocated to it. Now, for us, we are going to be specific. We are going to follow the tank. Now, if someone sustains burns of the tank, if they have not told you to say it is posterior or anterior, you are going to use both sides of the tank. So, the anterior trunk, it's 18, and the posterior trunk, it is also 18, which is going to give us 36%. Okay, so we have our 36, and here we are going to assume the patient has the weight of 50 kg. So now that we have the information, we want to replace this information or information or data in our particular formula so that we find how many meals the patient will receive in that particular 24 hours. So let's replace our information. So it will be 4 meals, of course, times our percentage. We are going with 36 since we have used the tank, both posterior and anterior. So 36%. Then we are going to multiply by the patient's weight, which is 50 kg. Okay, now that we have information, if we are going to follow your simple mathematics here, if you multiply 4 times 36 times 50, you are going to have 7,200 meals. Okay, now this 7,200 meals, these are total meals the patient should receive in 24 hours. Okay, now you need to distribute. This formula goes on further and distributes these meals in terms of how much at that particular time the patient should receive. Of course, it's under 24 hours. So according to this formula, here is how it goes. You are going to give half of the total fluids. So half of the total fluids. So half of the total, meaning you are going to multiply by this. So half of total fluids you give in the first 8 hours. Okay, now what is half of this? Of course, half of this will give us something around 3,600 meals. Okay, then we have taken out the first 8 hours. What about the second 8 hours? So we are going to give quarter of the total fluids in the second 8 hours. Okay, now what is the quarter of these fluids? Of course, it will be the same as dividing 36 by 2, which is going to give us, of course, it will give us 1,800 meals in the second 8 hours. Meaning, the remaining quarter of the fluids you give also in the third 8 hours. which is 1,800 mils. Now, what we are simply saying here is that the total fluids you had calculated or you had found, which is 7,200 mils, or in short 7.2 liters, you are going to give half of the total fluids in the first 8 hours. Very, very important. Then what will remain, the other half which is going to remain, you are going to divide it by 2 and give in the second and the third 8 hours. Remember, each 24 hours has how many 8 hours? Each 24 hours has 1, 2, 3. So half there, then you give quarter, and the other quarter. So this has been the first example. Let's look at the second example and see how much we are going to, or how we are going to apply this Parkland's formula in terms of fluids administration. Let's look at the second example. So in this example number 2, let's first write the formula. So Parkland's formula is equal to 4 mils times the total body surface area base times the patient's weight. Now, in this example number 2, the patient has sustained bends. Let's follow here critically. The patient has sustained bends of the trunk, which is both anterior and posterior, 18 plus 18, which is giving us 36%. And the patient has also sustained the bends of the leg, which is both lower and upper, 9 plus 9 is giving us 18%. And the same patient has also sustained bends of the hand. Then you are going to say 4.5 plus 4.5, which is giving us 9%. Okay, now the same patient has the weight of 70 kg. Let's fill this information in our formula and calculate now the total fluids the patient will receive in the first 24 hours. Remember, everyone who sustains 25% and above needs medical or fluids resuscitation. So let's replace this. So it will be 4 mils times the percentage, which we are going to add, which is 36 plus 9 plus 18, times the patient's weight, which is 70 kg. Okay, so it will be 4 mils times, if you are going to add this, it will be 63% times 70 kg. Now, the total of this will give us the total amount of fluids the patient will receive in the first 24 hours. So if you multiply 4 by 63 times 70, it will give us something around 17,640 mils. So these are the total fluids the patient will receive in 24 hours. Now, according to Parkland's formula, we need to calculate, we need to find out. Remember, we need to distribute these fluids in 24 hours. Okay, so according to this formula, it states that the first half of this, so half of total fluids, you give in the first 8 hours. According to our calculation, what's the half? Of course, the half here will be somewhere around 8,820 mils. So this 8,820, or in short 8.8 liters, this is the total amount of fluids you are going to give in the first 8 hours. Then it also states that the second quarter of total fluids you give in the second 8 hours. Okay, so the quarter of this total fluids here, which we have, is 4,410 mils. Okay, then of course the last quarter of the fluids, meaning 1/4, of course, of the total fluids, you give in the third on the last 80 hours, which will be 410 meals. Now, what does this imply? This implies that after calculating 17.6 liters or 17,640 meals, you need to give it in the phases of 8 hours, 8 hours, and 8 hours. So the first 8 hours, you give half of this. So what is half? It is the 8.8 liters or 80,820. Then the second, or the remaining half, you distribute it into 2 8 hours. Remember, every 24 hours, every 24 hours has about how many hours? 2 8. I mean 3 8 8 8. So you give half in the first 8 hours. Then you give quarter in the second 8 hours. And the last quarter in the last 80 hours. Okay, and this is how you go about fluids calculation and fluid circulation using Parkland's formula. Very, very important to remember the formula. Apart from remembering the formula, remember always the total body surface area base. Using the rule of 9 very critically. Okay, so thank you very much. This has been Mr. Dibo showing you or demonstrating how to calculate fluids using the Parkland's formula. If you are watching us for the first time, subscribe for more videos and insight on how we do this. Thank you very much for watching.